Okay. Good morning, everyone. We are going to do a quick activity on how a computer character would respond to the commands you give it. And in order to do that, we're going to set up a quick maze in the room. One person will be the character. They will wear a blindfold so they can't see the field. There's a reason for that, which we will explain at the end of the activity. And then one person will be giving the commands to the character, and the other person will help set up the field, and then we'll rotate through that activity. So if you'd like to hold your blindfold for the moment. Okay. Who would like to be the first volunteer to go through the maze? Who would like to be the first volunteer to give commands? Who would like to be asleep right now? Oh, okay, at least, okay, you guys are listening, that's good. Okay, so, would you be my first volunteer to give commands? Would you be my first volunteer to go through the maze? And Jared, you'll be my first volunteer to help set up the maze. Okay, the reason why we're going to do it this way is, in each row, you'll pull out one chair. And the person starting and walking will be over there, and the person guiding will give the commands, walk straight 3 steps. Turn right 90 degrees, turn left 90 degrees, walk straight. And then they have to get them through all 4 rows of chairs. Okay? So, if you're going to be our first walker, please start over there with your blindfold. You're going to be the first person to give commands. You can either stand at one end or the other. That's fine. And then Jared, we're going to pull chairs out as soon as she gets blindfolded. So you can pick one chair in each row to pull out. Okay, would you like to blindfold yourself, or do you need help?
Probably need help.
Okay.
Maybe not.
Maybe not? Are you good?
Yeah.
And again, you can hold it in place. It's all about not knowing or anticipating what the command is going to be. Okay, so pick up his starting position when you're ready. Stop right, go to your forward a little bit. Stop, turn right 90 degrees. Now stay right there. Now, you can pick one of the chairs in each row to pull out. Slide it over there. Which one here? Which one, you know which one in this room? And then pick one in the last room. Okay. Programmer, you see the path, correct? Okay, so remember, you're only responding to commands that are given to you. Understood? Okay.
Okay, turn right 90 degrees. Walk 1 step forward. Turn left 90 degrees. Take 5 steps forward. Take 5 steps forward. Okay. Okay. Take 2 small steps forward. 1 more step. Turn left 90 degrees. Shift over to your left a little bit. Again. Shift again. Okay. Take 3 steps forward. Wait, stop. This way. Turn more to your left just a little bit. Like turn a little bit. Oh. Yeah. No. Yeah. Okay. Take 3 steps forward. Okay. Turn right 90 degree angle. Move forward 4 times. Okay. Turn right 90 degrees. Okay. Move 1 step forward. Move another step forward. And now turn left. And take 3 steps forward.
All right. Nice job.
Woohoo!
Okay, so take a look at the path you came through. All right, now let's just talk about some of the commands that were given and some of the things that happened during the activity. First of all, any keywords you can see that came out throughout, other than move and turn. Like what complications arose that you had to correct for?
The shifting.
Okay, so her turn wouldn't be perfectly 90 degrees.
Yeah.
And a robot will do that. It'll turn exactly what it thinks the right amount is, but it may not be perfect. What else? What else happened during walking, or what else happened during commands?
Did you find trouble trusting that I wasn't going to bump into it?
Okay, so certainly a trust issue. We don't have to worry about, like robots don't worry about trusting. They would drive right off a cliff if we told them to do that. But we have the human factor, right? We're not going to just blindly follow instructions. All right, so what else? What else? Okay, so when you, assuming you could trust what the person did, tell me a couple things that happened while you were walking through that you encountered that if you had been able to watch what you were doing.
Chairs.
Okay, so you bumped into things occasionally, right?
Yeah.
So how would a robot compensate for that? We give it a command, and how would a robot compensate for that?
Try it again.
Okay, so we could do a trial and error, and then like we try once and then do it again and correct maybe the distance, because then you had a little bit more. Now, a robot wouldn't necessarily know what a little bit more is, unless you pre-programmed a routine to say a little bit more. But what would a robot use to compensate bumping into an object? Have you gotten that far yet?
I don't think so.
Okay, so a robot, why do we blindfold you? We said we would talk about that. Why do we blindfold?
So I can't see where I'm going.
So you were blindly following commands. You weren't compensating based on your vision. And your vision, if she said turn left 90 degrees, and you turned, if it wasn't perfectly 90 degrees, you would have compensated. If you were walking and weren't walking straight, you would have compensated. But following exactly the command that was given is really what a robot or a computer program is going to do. It's not going to compensate unless you program it like with a little bit of intelligent logic, meaning like walk forward, but if you get too close to a chair, then shift a little bit. See, that's how a robot or a computer program would respond to that.